to show you how to turn on the Speroni tool presetter. Depending on how your shop chooses to do this, you can either turn it on with the power switch or just turn on the PC that's located here in the cabinet. The Speroni operating system runs on a Dell PC, and it's kept in a nice ventilated cabinet located underneath the bench. The software will go ahead and load up and will immediately prompt the operator to log in. Now the software is going to go ahead and boot up according to my access levels. Once you're logged in, you'll be automatically prompted to home your machine. To do this, you just move the axes, Z and X, and you'll notice that that homing prompt disappears and your numbers are now green. Next, we're going to calibrate the spindle. First, you need to choose the spindle under adapter management. Just double click and you'll notice it's been selected here on the screen. To move the spindle when you have retention on clamping, you need to activate the spindle clamping mechanism in order to move it. Come down and measure the calibration notch. Get it into focus. When you have the green bar, you know it's in focus, so from one operator to the next, it will be consistently measured. Then we'll come down and click on adapter management and confirm. Now the reference point exactly matches what you've measured in the output fields. This is also the same values that are ground on each individual spindle. Calibration has now been completed and you're ready to measure your first tool. So we'll highlight the spindle and adapter management, move the spindle, measure the calibration notch, bring it into focus, select the adapter calibration button and confirm. Calibration has now been completed. In order to achieve the guaranteed standards in accuracy and repeatability, it's imperative that you keep your unit clean. Using the spindle cleaner is an easy way to make sure you don't have any contaminants in your spindle. And when you're measuring, occasionally you'll notice pieces of fuzz, and it's simple to just clean off your measuring edge with the cleaning putty. Now we'll measure our first tool. Loading the tool into the spindle, you'll want to do dimple away from the drive key. Activate the clamping mechanism to assure that your tool has been seated. Go ahead and move the camera so that it will pick up the desired measured edge. You'll rotate the spindle to bring it into focus. When you have the green bar, you know it's in focus, and your outputs are displayed in the green numbers above. I'd like to show you some of the easy measurement functions on the Speroni. When you have an insert, it's a click of a button to measure the nose radius, top angle, bottom angle, and included angle. When you use the same tools again and again, it can be very useful to load in some simple tool data. With this boring tool, I inputted the theoretical values as well as tolerances. So when this tool is selected, it will let me know if it's out of tolerance. Right now the diameter is out of tolerance. As you can see, the diameter offset is displayed with red and yellow. To adjust it, I want to make sure my spindle brake is turned on so that the tool doesn't move during adjustment. And I'll rotate the dial to bring it back in tolerance. And as soon as this tool is brought back into tolerance, the numbers will change from yellow on red to green on black. Once your desired measurement has been achieved, you can print a label with the click of a button. And your offsets will appear on the label with the tool's identity. Another way to store your measurements is by saving them to the measure results list. You'll verify your reference point, which is the 50 taper spindle, since this is a 50 taper tool, and it will be added to the list. To use the Episcopy, you simply turn on the adjustable light, and the ring light will turn on. You can also toggle between radius and diameter measurements, as well as inch to metric. Next, we'll be showing you how to capture the maximum profile of a multi-fluted tool. First, you'll want to locate the tool's measuring edge with the camera. Then you'll activate the max B function by clicking on the button on the top right-hand corner of the screen. You'll notice that the image turns to gray. This is where the tool is currently positioned. As you rotate the spindle 360 degrees, you'll see that each flute in gray passing through, and the black image is capturing that maximum profile. The offsets are listed above. A great benefit to using a camera-based presetter system is that it will automatically focus on your tool's image. So as you see, when I rotate the spindle, the crosshairs actually move with the tool's image. And then you know you're focused when the green line appears. The old style would have a fixed axis, and you would actually have to manually adjust to get the image on the line. There was a lot of potential for operator error using this method. Software advancements have allowed the operator to do a lot more than simply measure the maximum length and diameter of your tool. SPERONI has an excellent runout feature. Activating the feature is the click of a button. You'll notice that there's a red and green bar that appears on the screen. This now becomes the check range. As each flute passes through the check range, the measurements are plotted on a graph to the left. There's one graph for the X values and one graph for the Z values. You can visualize the variation looking at the graph and also check the numeric values above. The runout is clearly displayed under the range category. This is a great way to detect if the runout you're experiencing is of an individual tool or to determine if it's possibly in your machine tool spindle. SPERONI's camera will magnify the image 45 times for a display of 6 millimeters by 4.5 millimeters. Occasionally your tools will not fit in this window, and you'll need to learn some tricks to be able to get around this. So what we do is measure one area at a time and freeze that dimension, and then put the two together. So first, we'll measure the length of this carbide tool. We'll freeze the dimension by activating that function and selecting the Z value to freeze. Then you'll move the camera to the next desired measurement point, refocus, and now you have the correct diameter and Z values, even though you weren't able to capture both on the screen at the same time. There will be times when you will need to incrementally measure the distance from one point to another. To do this, you will utilize the incremental mode function. In this next example, we'll be measuring a step boring tool. We'll be looking at these two inserts here, the first one making the bore hole, and the second making the chamfered edge. First, we'll be measuring the insert making the bored hole. We'll measure this value, capturing the maximum length and diameter. We'll then put the values into incremental, zeroing out X, and Z. Then we'll rotate to the chamfering insert and adjust so that the diameter value goes back to 0, the same diameter that it would have been on the other side. To make sure we have the actual point, we need to select a single point measuring icon. We'll bring the value back to 0, and now we've determined what the absolute distance in Z was from the same diameter on the one insert to the next. The SPERONI is equipped with over 120 measuring icons. They're all located in one library. We'll open the library up, and you can see by clicking on the arrows you can scroll through and see the different measuring icons. When you find one that you can use, drag and drop it into the favorites. These favorites will then appear on the main screen. In our next example, we'll be showing how to use one of these measuring icons. We'll be measuring the pitch on a thread mill. I'll activate the icon by clicking on it, and then you'll want to click on the screen so that the measuring boxes appear. I'm able to drag and drop each measuring box to go to the appropriate spot. Each box is measuring a line of best fit that will create an angle. Those angles come together, creating a theoretical intersection point, and the pitch is the difference from one of those intersection points to the next. So far, we've seen our tools being measured in quick gauge mode, but to utilize the preset functions, you'll need to first load some tool data into the database. To access this information, I'll highlight the tool on the list and pull up its identity by clicking on icon number 10, Show the Tool's Data Management. This will pull open a secondary screen which utilizes all of the tool's data. You can attach pictures, drawings, or any type of attachment for reference. You can assign the tool a tool code, give it a description, reference its 0 point, which in this case is the 50 taper spindle, determine if it will be in inches or millimeters, diameter or radius. For this finished boring head, we just have a single cutter listed here. This data has been inputted with theoretical values for X and Z, as well as upper and lower tolerances. Now we will measure this tool in preset mode. We'll go to the main menu and select preset. The tool was first on the list, so it's already highlighted. All of the theoretical values carry over from the data management screen. So all we need to do is measure the tool, then we'll click Save, confirm that we are using the correct adapter, and the data will overwrite the previous measurement. If you were to post this offset directly to your machining center, this is the data that would be used. Now we'll show you how to enter a new tool into the database. This time, we'll access the database from the main menu. We'll select Tools and highlight a blank line, then select Add the Data to the database. Now we have a blank screen to add the data for this tool. This is the number I'm going to use for the tool code. Next, I'll fill in the description. And select the 50 taper spindle. We'll measure this in inches and diameter. To find the theoretical values, I'm going to take an actual measurement. picture. All of my data has been inputted. I'm going to confirm this operation. The tool has been added into the database, and now I would like to preset it. The tool is highlighted, and I'm simply going to measure it again. Once this data is inputted into the presetter, it stays there until it was manually overwritten or deleted. Again, I will freeze the Z dimension and rotate to capture the maximum diameter. Now that I have both values, I'm going to save them. And the values have been overwritten. This tool has now been preset. Now that we've measured a couple tools in preset mode, I'm going to show you how to post those offsets directly to your machining center. From any screen, you can access the main menu. From here, I'm going to highlight the icon labeled Post Processor. I can either select to post an entire job or individual tools. In this case, I'm going to select the two individual tools that we measured earlier. Next, you will select which control you want to output your offsets to. This will determine the format of the code. SPERONI is able to interface with numerous different types of controls, and we will work with you individually to make sure that your needs are met. You will also select your output selection. The most common way to do this is to post it to a file on your shared drive. That way your machining centers, which are also networked, will be able to retrieve that file. We'll hit generate, and you can see the code generated in the background for the two tools that we've measured. The front screen shows the folder tree in which you will select which folder you would like this file to be saved to. Next, I would like to demonstrate the accuracy and repeatability of the SPERONI tool presetter. I'm going to measure this tool twice and show you that we get the same measurements. We'll go ahead and measure this tool and bring it into focus. Now I'm going to put it into incremental mode and zero out the X and Z values. That way we'll be able to easily detect if we didn't get the exact same numbers the second time. I'll move the camera away, remove the tool, move the spindle, and do everything again. The SPERONI MAGIS model will guarantee accuracy of 1/10. It also guarantees repeatability of 3/10, even at the full measuring range. One of the great things about all SPERONI tool presetters is that they are not confined to a clean room environment. In fact, they're perfectly suitable for your shop floor environment. From the anti-vibration pads, to the cast iron base, to the protective bellows and hardened plastic covers. This machine will withstand temperature changes, contaminants, and vibrations in the floor, and will not compromise the accuracy or repeatability of your measurements. The Tool Pro is a great accessory item commonly paired with a tool presetter. I'll demonstrate the Tool Pro now. We'll place a tool in the tapered portion of the Vario adapter. The tool will locate using the drive key, and it will lock in using the flange pin. This allows you to push the button, and it will index every 45 degrees, allowing you to safely make adjustments, assemble and disassemble your tools. To remove the tool, simply pull on the flange pin and lift the tool out. Integral versions of the Tool Pro are available. We also have a Tool Pro Varia, which means you can switch out the adapters by pushing the gold button in the back and releasing the tool holding portion of the Tool Pro. We'll grab a different size, again push in the gold